Greetings, everyone. Through here. Welcome to another exciting episode of the Demo Hub. Excited to have a guest with us today. Dave is the co-founder of a tool called Estuary in the real-time streaming and integration ETL space. I'm excited to have Dave on the show today to talk to us about Estuary and, more importantly, to see a demo of the product. Dave, welcome to the show.
Hi, thanks for having me. And I'm excited to be here to show off our product.
That's awesome. Let's jump in for the folks and the audience who don't know about Estuary. Can you give the elevator pitch of what it is and where it fits within the modern data stack?
Sure, no problem. So we are a managed streaming ETL product. And what that means is we make it very easy to work with real-time data and keep low latency copies in whatever tool you want to use. So if you want to use Snowflake, we can make your Snowflake a real-time view of your data. If you want to use a Redis store for key value store and you want to use that for serving purposes, we can help you keep an exactly same copy of that data in the Redis store. So you'll have the same view for analytics or operations. And that's essentially the very high level of what we do. We give you the tools to do all the things you need across that streaming stack. One would be capturing your data from sources, transforming it because you need to repackage it and make it more efficient for your analytics tools to actually query or your operational tools to use. And then materialization. So keeping a low latency view up to date in whatever system you want, like Snowflake or Redis or Mongo or whatever you want.
That's pretty fascinating. If I just put on my hat of integration, would this fall under CDC, change data capture, or where would you put this within that spectrum of tools in the modern data space?
Yeah, CDC is one of the tools that we offer. We offer change data capture on the capture front. So you can capture from various sources, APIs or databases like MySQL or Postgres or SQL Server using change data capture. But it really is the full view. So one tool where you can capture the data, transform it, and also keep, that low latency view across your products.
One question my legacy had here with a pattern, or you might call it an anti-pattern of CDC, and you throw in like a Debezium, Kafka, then you're writing that into your enterprise data warehouse. How does this reimagine that?
There are a few pieces that are really nice about it. I'll start at the beginning, capturing data using a system like Debezium. Debezium's great. It's pretty easy to set up for the first time you're using it. Whenever you take on a piece of infrastructure like that, you're agreeing to use it and maintain it for a very long period of time. It does have problems when it comes to higher scale use cases and exactly one semantics. So under the hood, we're not using Debezium. We've actually rolled our own CDC framework. And that means that we're able to offer exactly one semantics at multi-terabyte scale, which is something that you don't really get from Debezium. The same thing goes with Kafka, right? Kafka is a great system. And if you have an extra few engineers, you should totally use it. But it definitely requires care and attention to be able to use and maintain over the long term. So our philosophy around the system is try to use it just to create value, right? Instead of having to care and maintain and manage all of these things that are fit together. One of the things that we leverage when we designed our own system is Netflix put out a publication around this concept that they had, which is DB log. And DB log basically says the way that Debezium captures data, it can't be exactly one semantics, and it's hard to do big backfills. We make that a lot easier just by essentially creating a watermarks table and being able to write progress to the database from that to the watermarks table.
Pretty awesome. You've touched on a lot of the capture side, the SQL and the APIs. On the legacy side, do you have abilities to pull data from SAP system, or do you focus more on just the relational database?
It's relational right now. We are adding Oracle, so Oracle will be an option coming in the next few weeks. But SAP is not something that we've targeted yet. That's going to be a very big undertaking and a lot of grumpy engineers when we do decide to target it.
What is the turnaround for getting a connector? Have you run into systems where you don't have a connector yet and you have to build new connectors for those?
Yeah, for sure. So we build all of our millisecond latency connectors, the ones that are materializations to a destination system. Those take us about a week to two, depending on the complexity of the system. It could take a little longer for some of the more complex ones, like I'm sure Oracle will be quite a bit longer. But we can also leverage connectors built by other companies, and we can pull in data from SaaS systems, for instance. Like if you wanted to use us to pull in data from Stripe's API, you can do that. And we built real-time connectors to the ones that allow for that. So for instance, Salesforce, we have a real-time connector for, but where they don't have a real-time option, we actually can just directly leverage Airbyte connectors as well. So you can pull anything in from those as well.
Oh, that's actually a good point. So you can leverage your Airbyte framework and the connectors they have for integrating data in real time,
That's
correct?
correct. Yeah.
Because there is this open source framework called Singer by Stitch Data that got
Mhm.
acquired by Talent, but Airbyte was leveraging that framework. So do you have any opinions about that?
So under the hood, all Airbyte did really, one of their biggest innovations was packaging all the Singer frameworks and other frameworks, putting them all together since they're all open source into one repository. That's like one of the biggest things that Airbyte did. So you have this one repository you could go to and it had Singer plus, there was a bunch of other lies and, other companies that did the same thing. So that's one of the biggest things that they did. I think there are companies behind the Singer framework, right? Like Meltano is one of the big ones that are now representing the Singer framework. I think long term, we'll want to support anything. Like you can bring anything to it. Short term, we haven't really gotten requests that aren't covered by the stuff that we have internally. Plus, if we want to add Airbyte too, we can.
Okay,
But
that's
I think
awesome.
that they're all good frameworks that have communities behind them. I think there's also some cool closed source connectors out there as well, which we would love to integrate at some point as well. It's long term. I think there'll be a lot more connectivity between these ecosystems and frameworks, hopefully.
What is the pricing strategy? Is it for volume or
It's per volume, exactly. So after the 20 gigabytes per month, it's 75 cents a gigabyte. Streaming data, real-time updates, and that's it. So we try to make it as straightforward as possible.
all right? And you mentioned that it's also open source, so you can go build it from GitHub if you wanted to and leverage your connectors then.
Yeah, absolutely. You can use the whole product for free, either in the managed tier or in the open source version. Definitely a little easier to get started on the managed tier just because it's a distributed system. This system auto scales for you under the hood. There's a lot of complexity that's going on under the hood.
Let's jump into the demo, as a lot of the audience are very eager to see what Estuary is all about.
Sure. So let's just get started. I'll show you the punchline before anything. So what you're seeing right here is a Google Sheet that's being updated by Estuary Flow. And it's doing updates every about 1 second. And that's because that's as fast as Google Sheets allows you to update it. Um, Otherwise, they start rate limiting you. So our system is managing this update. The data source is Wikipedia data. So the Wikipedia publishes a streaming API, which our system is using. And it's taking that stream of about 100 updates per second, every single edit to a Wikipedia page that happens. And it's then condensing that into a fact table that's updated as quickly as possible and is always available on this sheet. So this is just a demo, but you could use it for anything, right? Like if you have an API, our system could capture from that and present you an aggregated view of it. So here's the login screen that you see when you actually go into our product. And what I'm going to show you is how that is set up, how you would actually go ahead and create that facts table that has an aggregated view of data within Google Sheets. So there are 3 legs to the system. The first I mentioned is captures. I mentioned there's materializations. I'm going to go through those 2 first, and then we'll show you how the transformation was made afterwards. But captures are done using a very, very simple UI. We have this demo, Wikipedia recent changes. You can see today it captured about 2.7 gigabytes of documents, data, 2.32 million changes. That's way more than a Google Sheet can handle. So obviously we need to do something there about it. If we view the details of this thing, this is a very low level view that you're seeing here, but it kind of shows you the configuration in the system. When you actually go and set this up, you can do it in a much simpler way. So this is using an HTTP web capture, HTTP file capture, which just needs a file URL. So Wikipedia's URL, which they publish in their docs, can go right here. I believe we needed to add headers just to make it a JSON format. But besides that, that was all it took to get this going. So this actually can capture from a lot of APIs just with this one single type of connector that we have here. We have other connectors too. So, some of the more popular ones are like the database connectors, such as SQL Server, where you can capture data using CDC.
That's awesome. Just a quick question. So is it completely SaaS based or is there a version of this that being run on premises hosted?
Right now it's
What is,
SaaS based. We are planning an on-prem deployment for the CDC specifically, which would be not this quarter, but potentially next quarter. So yeah, this is the high level of how you capture data. Once you capture data, it goes into your own cloud storage. So we capture that. We also manage the real-time rights. So you get both the historical data and the real-time data and aggregate it into a data lake in your own cloud storage. Those are as collections, which you can kind of see in the product here. The one that we just created was recent change. That's what's coming in from your source system. And you can preview some of the data, see what it looks like directly from Wikipedia in our system here. These are a few different documents. So before I get to how we up level this information and transform it into a fact table, I'll show you what it looks like on the other side, which is the materialization side. So all we did on the materialization side was use our Google Sheets connector, create a new Google Sheets materialization, put the spreadsheet sheet link URL, and sign in with Google Sheets, and that's it. You're set. It will automatically create that and manage the updates for you. So we're pushing a couple of updates right now that are going to make the transformation experience really nice and pleasant within the UI. Very soon, you'll be able to go and select collections of data, click transform, and then be taken to a web browser where you can transform that data. But for now, that happens in using our command line tool and the system of your choice. So let me show you a different screen. Our newest feature that's going to be added will be the ability to do what I'm showing you right now in my VS Code terminal in browser. So you'll be able to click on an entity and be able to create a transformation of the data that you care about right in a browser. So it'll be a little bit more straightforward to set this up. You won't have to install command line tool or anything, which I've done here. So you can see here, I'm going to just show you that I can pull down the actual transformation that was pre-created here using our command line tool. That gets laid out to me as files in cloud storage. And this is the transformation that's aggregating that data. It's a pretty simple one. All it's doing is it's restructuring the date format because I cared about it in a different format than what Wikipedia gave to us. And it's telling us that I want to emit one document for every line changed, edit. By the way, in the next 2 weeks, we'll be adding SQL transformations as well. So those will be a little bit more approachable to the average user.
and Python?
Python's a little later. It's not quite yet, but yeah,
Okay.
eventually we will be adding that as well.
All right.
But all this is doing is changing the shape of the date field and creating a fact table with 4 fields in it. These 4 fields are aggregated through every single event, and then the system and the runtime actually up levels that into an aggregated table. So that's really it. That is the system in a nutshell.
That's awesome. Is the product GA yet, or where is it in the go-to-market lifecycle?
So we are GA. You can go to our website. That's Estuary.dev and register, and you'll be able to sign up for our free tier. So you can actually use it perpetually for free at lower scale. We give you 20 gigabytes per month in usage. So that's actually reasonable scale. Yeah. For personal use cases is what it's intended for the free tier.
Yeah, it's very fascinating to watch. Any last words for the audience in terms of where to find us, how to get started?
Yeah, no problem. So our website is Estuary.dev. Feel free to go there, check it out. It's a free product, free for life for 20 gigabytes a month. And feel free to reach out on our Slack community if you have any questions.
Yeah, that's awesome. Dave, thanks for coming on board the Demo Hub.
Thanks for having me.